The universe is a vast and mysterious place filled with wonders that defy our understanding. Today, we're diving into 10 mind-blowing facts about the universe that just might change the way you see everything around you. Did you know that the universe is not only expanding but doing so faster than the speed of light? This isn't science fiction. It's a fundamental aspect of our universe, driven by a force we call dark energy. Imagine a loaf of raisin bread baking in the oven. As the bread rises, the raisins embedded within it move farther apart. In this analogy, the raisins are galaxies, and the dough is the fabric of space-time itself. Now imagine that dough isn't just rising, it's expanding at an accelerating rate. That's what we observe in our universe. The galaxies are not just drifting apart, they're racing away from each other at speeds that boggle the mind. This expansion, propelled by dark energy, has profound implications for the future of our universe. The study of this expansion and the mysterious dark energy that drives it is one of the most exciting frontiers in modern astrophysics. We often think of the universe as being filled with stars, planets, and galaxies. But what if I told you that all of that, all the matter we can see, makes up only a tiny fraction of what's actually out there? About 85% of the universe is made up of something we can't see or directly detect: dark matter and dark energy. Let's start with dark matter. We can't see it, but we know it's there because of its gravitational effects on the things we can see, like galaxies. Imagine a spinning galaxy, its stars whirling around the center. Based on the visible mass of the stars, we'd expect those stars to fly off into space, flung outward by their own momentum. But they don't. Some invisible stuff is holding them together. That stuff is dark matter, providing the extra gravity needed to keep galaxies from flying apart. Now, onto dark energy. This mysterious force is responsible for the accelerating expansion of the universe. We don't know what dark matter and dark energy are made of, but their existence has revolutionized our understanding of the cosmos. Black holes are among the most fascinating and enigmatic objects in the universe. They are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. Picture this: a massive star, many times larger than our sun, reaches the end of its life. It has burned through all its nuclear fuel, and there's no longer enough outward pressure from nuclear fusion to counteract the inward pull of its own gravity. The star collapses in on itself, its core collapsing into an infinitely small point called a singularity. This singularity is the heart of a black hole, a point where density and gravity become infinite. Surrounding the singularity is the event horizon, the point of no return. Once you cross the event horizon, there is no escape from the black hole's gravitational pull. And while we can't see black holes directly, we can detect their presence by observing their effects on surrounding matter. If black holes represent the ultimate collapse of matter, then neutron stars are their equally bizarre, ultra-dense cousins. Imagine a star more massive than our sun squeezed into a sphere the size of a city. That's a neutron star. These incredibly dense objects are born from the death throes of massive stars that weren't quite massive enough to form black holes. When these stars explode as supernova, they leave behind a core that's compressed to unimaginable densities. A single teaspoon of neutron star material would weigh billions of tons on Earth. That's about the same as Mount Everest. Some neutron stars, known as pulsars, spin rapidly, emitting beams of radio waves from their magnetic poles. The next time you're at the beach, take a moment to look at the sand. Each grain represents a tiny speck in the vastness of our planet. Now try to imagine a number so large that it dwarfs even the countless grains of sand on all the beaches on Earth. That's how many stars astronomers estimate are in the observable universe. We're talking about trillions upon trillions of stars, each one a giant ball of burning plasma, fusing hydrogen into helium and releasing unimaginable amounts of energy. And that's just the observable universe, the portion of the cosmos that we can see from Earth. The actual universe is likely much, much larger, perhaps even infinite. In the vast expanse of space, galaxies aren't static islands of stars. They move, they interact, and sometimes they collide in spectacular displays of cosmic violence. These galactic collisions are some of the most dramatic events in the universe, reshaping galaxies and triggering the birth of new stars. Imagine two spiral galaxies, each with their majestic spiral arms, on a collision course. As they approach each other, their gravitational forces begin to distort their shapes, drawing out long streamers of stars and gas. The galaxies pass through each other, their stars and gas clouds interacting in a complex cosmic dance. Over millions of years, the galaxies merge, their spiral arms disrupted, their gas clouds colliding and collapsing to form new generations of stars. Our own Milky Way galaxy is on a collision course with our nearest galactic neighbor, the Andromeda Galaxy, but the merger will create a spectacular light show in the night sky. One of the most mind-bending concepts in physics is the idea that time is not absolute but relative. This means that time can flow at different rates depending on your relative motion and the strength of the gravitational field around you. This is one of the key insights of Einstein's theory of general relativity, which describes gravity as a curvature of space-time. Imagine a clock placed near a massive object, like a black hole. The strong gravity of the black hole warps space-time around it, causing time to slow down in that region. To an outside observer, the clock would appear to tick more slowly as it gets closer to the black hole. This effect, known as time dilation, has been experimentally verified. Time dilation has profound implications for our understanding of the universe. Throughout history, humans have pondered the nature of the universe and its boundaries. Does the universe have an edge? And if so, what lies beyond it? The answer, according to our current understanding, is that the universe doesn't have an edge in the traditional sense. This is because the universe is not a three-dimensional object embedded in a larger space. Instead, the universe is all of space and time itself. Imagine a balloon being inflated. The surface of the balloon represents the universe, and as the balloon expands, the distance between any 2 points on its surface increases. Now, imagine that the balloon has no center and no edge. That's a simplified way to visualize the geometry of the universe. The universe is expanding, but it doesn't have a boundary or an edge. We often think of ourselves as separate from the cosmos, tiny inhabitants of a small planet orbiting an average star. But the truth is far more profound and interconnected. We are, quite literally, made of stardust. The atoms in our bodies, the iron in our blood, the calcium in our bones, the oxygen we breathe, all were forged in the nuclear furnaces of stars. Billions of years ago, long before our solar system existed, massive stars lived and died in this corner of the galaxy. These stars, through nuclear fusion in their cores, created the heavier elements that make up our world and ourselves. When these stars reached the end of their lives, they exploded as supernovae, scattering their enriched guts across the cosmos. So the next time you look up at the stars, remember that you are not just observing distant points of light. For centuries, we have contemplated the universe as a singular entity, a vast cosmic arena encompassing all that is. But what if our universe isn't alone? What if it's just one of countless universes, each with its own unique properties and laws of physics? This is the mind-boggling concept of the multiverse. The multiverse theory suggests that our universe is just one bubble in a cosmic bubble bath, each bubble representing a separate universe with its own set of physical laws and constants. These universes might be vastly different from our own, with different dimensions, different forces of nature, and even different laws of physics. Some universes might be hospitable to life, while others might be sterile and devoid of any complexity. While the multiverse remains a highly speculative idea, it's a tantalizing possibility that has captured the imaginations of physicists and cosmologists alike. It suggests that our universe, vast as it is, might be just a tiny speck in a much grander and more complex reality. The universe is filled with mysteries that challenge everything we think we know. If you enjoyed this journey through the cosmos, don't forget to like, subscribe, and join us for more mind-bending exploration.